Okay, welcome to this video, the third in our series on 5 random GCSE questions. And these questions are taken from a calculator paper and they're mainly grade 5 to 7 questions. Okay, the first of our 5 questions is about 3 of these tanks that are going to be painted. Okay, and each tank is a cylinder with a top and a bottom. And we've got to see if there's enough paint to cover the 3 tanks. So we can see straight away that the total amount of paint that we have is 8 tins, each tin covering 5. That would give us 40 square meters of coverage. So what we're interested in is seeing if the area of our 3 tanks is greater than or less than 40. Well, let's do a quick calculation. So if we imagine that we've got 3 tanks, then we're going to have 6 tops and bottoms, okay, 6 circles. So let's just do a calculation like that. So we have 6 times pi times the radius squared. The radius is 0.9, okay. So that's 6 lots of the circular top or bottom, okay. And we've also got 3 lots of the curved piece round the side. Okay, now the curved piece is a rectangle if you straightened it out, and the length of the rectangle is the same as the circumference of the circle. Okay, and the circumference of a circle is pi d, or 2 pi r. Okay, so pi d is pi times 1.8. And then we have to times it by the width of the rectangle, which is also 1.8. Okay, and because there's 3 of the cylinders, then there's 3 lots of that. So it's 3 times pi times 1.8, which is the diameter, times 1.8 again, which is the height of the cylinder or the width of the rectangle. And that is the total area. Now if we put that on the calculator, that comes to 729 pi over 50. Okay, and the calculator will present the answer to you in that form, and we need to evaluate that to make our comparison, and that comes to approximately 45.8. okay, and all we need to say is that 45.8 is greater than 40, and there's our comparison, and so therefore not enough paint. Okay, not enough paint. And that would answer the question for that. Okay, next question. The company has to make a large number of boxes, 6 machines. All the machines work at the same rate, okay? And it says when all the machines are working, they can make all the boxes in 11 days. So we have this concept of what we might call machine days. And 6 times 11 is 66 machine days. Okay, so what does that mean? Well, it means that if you had, for example, 3 machines, you would need 22 days. Or if you had 12 machines, you would need 5.5 days. In other words, the product of the 2 would always have to be 66. Okay, now in this particular situation, we know that some of the machines weren't working on day 1, day 2, and day 3, but after that, they all seem to be working. So we can do something like this. We can say that we've got 3 plus 4 plus 5, okay, that's taking the first 3 numbers, and then we've got some multiple of 6, Okay, and that has to equal 66. Okay, now if you add those three numbers together, you've got 12. So if you take that away from both sides, 6n equals 54, and n equals 9. Okay, now that's my working out, and that's telling me that I need 9 more days with all machines working, plus those first 3 days on limited machines, meaning that a total of 12 days is needed. Okay, so 9 plus 3 equals 12 days. And that's the answer to the question. Okay. Next question. We have a question about tax and interest. So interest is added to an account at the end of a year. It started with 6,000. So we had this amount I at the end of the first year. 6,000 plus some amount of money I for interest. Okay, we've got to find out really what that is first of all. Now we know that 20% of I is £28.80. So we could simply say that 0.2, okay, times I is equal to £28.80. Okay, now if we divide both sides by 0.2, I would be 28.80, okay, over 0.2, which of course is the same as multiplying it by 5, and that would give you 144 £144. So the interest is £144. That's the actual amount, but it says work out the percentage interest rate for the account. In other words, what percentage is 144 of 6,000? Well, we just need to put a fraction, 144 over 6,000, okay, and then times it by 100. And because this is a calculator question, you just need to write down what you're doing, okay, but you don't have to simplify fractions and things necessarily. You can just go straight to the calculator, and that will give you the answer, which comes out as 2.4%. Okay, that comes to 2.4, and that's the percentage increase. All right. Okay, next question. Okay, this is about density, and it's about combining two different materials with different densities. Okay, now the densities are not that different. Okay, 1.07 and 1.01. Okay, and we're combining different amounts of each. Okay, so we have to do a calculation that's based on the relationship between density, mass, and volume. I'll just remind you what that is. So if I just draw this triangle for you, okay, and like this, and basically it reminds us how to link the quantities together, density, mass, and volume. And it's simply that density here is equal to mass divided by volume. Okay, so what we can do is we can take the volume of the ethanol and times it by its density. Okay, so that's going to be 70 times 1.07. Okay, then we're going to add to it the 142 litres of propylene. Okay, so its density is 1.01, and that's going to give us the total mass of the new of these 212 litres. Okay, so we don't actually need to know what that number is. So on the top there is the total mass of all that liquid mixed together. And we know that it's got a total volume of 70 plus 142, which is 212. And it tells us that in the question anyway. And that is going to be the density of the new mixture. Okay, now you would expect it to be between these two numbers somewhere. All right, now if there were exactly the same volumes of each material, then the density would be exactly in the middle of these two. Okay, but they're not the same volume, so we need to work this out. And on the calculator, it comes to 1.0298. And you don't need to go any further than that because it says give the answer to 2 decimal places. So that's 1.03. Okay, and it's a density and it's in grams per centimeter cubed. Okay, to 2 dp. Okay, and that's the answer. And the last of the 5 questions, this is about a quadratic sequence. Okay, there's 2 methods you can use here. There's the algebraic method, there's the table method, which is really quite simple, and I think I would do that here. It won't take long at all. So we simply start by imagining the position in the sequence n. So the first term is 1, the second 2, the third term is indicated by the number 3, 4, 5, and so on. Then we put the sequence underneath, which I call capital S. So it's 1, 7, 17, okay, 31, and 49. I don't need to go any further. That's enough information to work with. Now I look at the differences. Now the first difference is 6, okay, and 10 and 14. And the second difference is simply 4, okay, and 4. So once I know the second difference, I halve it. Okay, half of 4 is 2. And then I work out 2 lots of n squared. N is 1, so 2 lots of 1 squared is 2. 2 lots of 2 squared is 8. 2 lots of 3 squared is 18. 2 lots of 4 squared is 32, and so on. 2 lots of 5 squared is 50. Okay, and then I just compare this with my sequence S, and I notice that if I subtract them, if I do S minus 2n squared, okay, I'm either left with a linear sequence or I'm left with a constant number. Well, 1 take away 2 is minus 1, 7 take away 8 is minus 1, 17 take away 18 is minus 1, etc. So I can simply state that this sequence here is just minus 1, and this is 2n squared. So the answer to the question is 2n squared minus 1. Okay, and it's easy to check that and see. Okay, if you take 2 times 1 squared and subtract 1, you get 1. If you take 2 times 2 squared, you get 8. Minus 1 is 7. 2 times 3 squared is 18. Take away 1 is 17. So it's very easy to see that that is in fact correct. And that's the end of that question. And that's the end of those 5 questions.